triangle where the height is 4 units, the base is 3 units. I know it's a right angle triangle because I can use my protractor to see that this is 90 degrees. See, we've attached a square. I also know that a square has to be the same sizing. So if this is 3, then I must have 3, 3, and 3. And if my height is 4, then I must have 4, 4, and 4. So that's where we're at so far. Okay. What is the area? Label the area of the square for the base and the height. Label the area. Owen, what's the area of my square attached to the base?
9.
Yeah, 9 square units. Good. Okay. Nine square units. Okay, Courtney, what's the area of the square attached to my height?
Entry point. 3 that's left. Very good. Only one man left.
What is the area of this square attached to the height of my triangle?
We have defeated them.
I don't know, I didn't get that.
Well, think about it. It's a square. Find the area. You know the side lengths are 4 and 4. What's the area?
16.
How do you find the area of a square? Side squared. What's side squared? So the side is 4. So what's the side squared? 4 squared. What is that?
Is the area 16?
Yeah, it is. Good. You're thinking about it too much. Okay, 16 square units. Okay, Atlas, I saw you freaking out there. Wanted to give her a chance. Even though I could see you wanted to help. Okay, I want you to also draw a square attached to this side. Okay? So, if this is the third side to my triangle, okay, I made it green there. That's my third side. How could I possibly attach a square to that now? What would you guys suggest I do? Because I know I need to have all 4 side lengths the same. How would you suggest I do this? How could I determine this length? How could I determine this length of this side of the triangle?
Let's go.
Oh boy, okay. So pay attention, pay close attention. I said this is units, and I'm basing this off of my grid paper. Okay? The grid paper units have no particular measurement. The second I introduce a ruler, I have measurement. Okay? So it depends on the units that I'm using here. So you can see here that if I start from 0, my 3 units on the grid paper is actually, what is that, 1.7 centimeters. Okay, is does that make sense to you? 1.7 is equal to 3. That's because they are different units. Okay, so, but we're going to use our ruler to help us. So we're actually going to measure this side length here. So yours might be different than mine. Kiddos, listen to this carefully. Your measurement, depending on your graph paper, might be different than mine. So you cannot use my measurement unless you're using the exact same graph paper as me. Okay? So you need to take your ruler and you need to measure from that one end, or 0, to when it hits the leg, the blue leg. So I need to get my head under here so I can see. Okay, what do I have here? 2.7 2.8 centimeters I have, okay? Now, squares also have to have 90 degrees. Okay, squares also have to have 90-degree angles in all four corners. So I'm going to use my protractor to help me with that. Where did I put my protractor? Oh, it slid under the document camera. Okay. So I need to have 90 degrees going from this corner. So I put my 0 there. Okay, I match my 0 with the slant. Okay, I'm gonna mark my 90 degrees up here. Okay, and I know I need to have 2.8 centimeters. So this is my little dot that I formed where the 90 degrees was. It's right over here. Okay, so I have to put my ruler, starting at 0 here. Okay, make sure it's lined up with my 90 degrees, but I'm only, like, I measured 2.8 right here. Okay, and I form a line. I did say 2.8, right? 2.8? Yeah. Okay. Okay, and I have to do the same thing over here on this corner. So I'm going to take 90 degrees. That edge. Okay, so I'm going to make another little dot up here so I know where my 90 degrees is. And, oh good lord. Yeah, I suppose I have to do this. Okay, so I make sure my 0 is lined up with my line. Okay, and I want to go to 2.8 here. Draw my line to that corner. Now I should be able to just connect these two, and it should also be 2.8. So if I look at my ruler here, from this corner to this corner of the square, that is exactly 2.8. So I've done a good job.
Keelan.
Okay, I don't know if you guys noticed here, but my corners have somehow matched up quite nicely to where these grid lines meet. Okay, so your square should look like this. Okay. Okay, so your task. Okay, I'm going to introduce a term to you. Okay, this side of a right triangle, okay, that slanted side of the right triangle is called the hypotenuse. Okay, the hypotenuse. So there's a new term for you. Okay, it is the side that is opposite the right angle. It is the side that is opposite the right angle. Also considered the longest side. Okay? Also, it is the longest side of a right triangle. So in particular, we're dealing with right triangles, and the hypotenuse is the longest side. And what I mean by the opposite side of the right angle is if you take a look at where your right angle is in your triangle, the hypotenuse will always be directly across from it. Okay, opposite. The hypotenuse does not connect to the 90-degree angle. Okay, I sure hope you guys are listening because I want nothing to do with when you guys come back to in-person. Because the last time we were online, I literally had someone come to me and be like, I don't remember you teaching me the word reciprocal. Okay, I want none of that. I don't want you guys coming back to in-person and going, Miss Simon, I don't remember you teaching me what the hypotenuse is. Okay, so make sure you're listening. So, this is the hypotenuse. I do not know what that side length is yet. I do not know what the length of the hypotenuse is. Okay?
So loud.
I want you guys to try to figure out a way. So what I'm asking you now is, what is the area of this square? Okay? So I'm going to send you off into breakout rooms for 5 minutes to discuss. Okay? Figure out a way how you could determine what the area is of this square. Okay? So 5 minutes in breakout rooms. I'm just going to do, I'm sorry kiddos, it takes me too long sometimes to come up with specific breakout rooms, and since you're only talking for 5 minutes, I'm just going to throw you in there. Okay? And it's for a short amount of time. So, that's my question. What is the area of the square that connects to the hypotenuse? How could you determine that? So, go discuss.
Well, this is easy. A squared plus b squared equals c squared, so... It's easy. Right side of triangle squared plus left side of triangle squared equals the bit.
I see the man.
So, what's going
Triangle
on?
plus triangle equals triangle. Done.
Yes. Side of right
like
triangle
something
plus
like
Side
squared.
of triangle
the
plus
wait,
triangle side.
They both
I
have
don't
to be
know.
squared.
I'm throwing a flashbang.
You in a CSGO match right now? Sorry.
What?
Understandable.
Oh, I got
Nice
a collab.
Oh wait, it's like measuring
Nice.
like what's the area
It's over.
of the triangle of the square we just made?
Using the op.
Oh.
The side of the triangle is 5.
Okay, thank you.
No, I don't actually know. Don't quote me on that.
Oh, okay.
Counter-Strike racially offensive.
Yeah, that's one of my videos.
Wow. This is great.
No. It's amazing. So 3 centimeters.
Are you gonna join us in CSGO, Lucas?
Yeah. I added you. Let me just launch.
I'm assuming you're KVK.
Yes. It was pretty easy to find you for the fact that you have a bacon.
Yep.
Yeah.
Topic. What is this
More like getting
music
high,
I'm hearing?
high.
Coming from Discord? Yes.
Dude, I've been playing so much fucking CSGO recently.
I'm just playing CSGO because I don't have any other games to really play.
Okay, let's go on CSGO. You know our rollout last night? We can do that.
CSGO speaks. And
Yeah.
lastly, just a free.
I just gotta join because it's next to me. Yeah. This stuff is easy. You don't even need time. All you gotta do is just look it up. Okay, join on me, Lucas. We're gonna go counter terrorist.
Let's go. Middle. We need help.
I'm joining right now.
Ready to go. Ready to go.
I told him how to get the formula.
I
The formula is a squared plus b squared equals c squared. Right side plus.
When you like told me to join shoes in my class, like that, like
I wanted to know what the Pythagorean theorem was early, so before this lesson I looked it up. Sorry about that, I didn't catch that.
a breakout room for
I explained how to do it, how it works, and what it is.
Let's move out.
I don't know. That seems pretty simple. And we gotta return to the main call in like 10 seconds.
In the middle. I'm at their entry point. Shut up!
Hey, cameras are back on. They should have stayed on when you were in the breakout room. Hey, I didn't get a chance to get into the last breakout room. But, I don't know why I even bother with the breakout rooms. If you go in there and you don't turn on your mic to have a discussion, what is the point? So, where is everyone? Oh, I'm still missing some people.
Lock and load. At the middle. At their entry point.
Keelan! Oh, he's just coming back. Perfect. Okay. So, in Keelan's group, Keelan said, I told everyone how to do it because he went Google or researched the Pythagorean theorem and looked up the formula. Okay, and that's all fine and dandy. However, that still doesn't answer my question. How do you figure out this area without that formula? Okay, so I did not give you a formula. How can I figure out this area right now without a formula? Okay, Keelan, what do you think?
You could take the area of the bottom square, the area of the other square, times them, and see what you get.
Sure, yeah, you could try that, right? Like, if we take 16 and we multiply it by 9, what do we get?
Grenade out.
Maybe, possibly, that's one thing we could try. Okay. One person in one group had said to me, well, what if you measure it? And I said, sure, we could measure this, but unfortunately with my ruler, remember I said this 2.8 centimeters that I get here is not the same as these units. Each of these units is not quite 6 millimeters. So that becomes complicated, right? Becomes a little difficult. So instead, we could have also thought to ourselves, well, maybe we can count these squares. When I look at this, I know I can count some full units, Okay, so I see a
Finally.
full unit square here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, yeah. Nope. 13. Okay, so 13 full squares I can definitely count. So for sure I have 13 full square units. Okay. Maybe I'm making some estimates here and I see that this partial piece here and this partial piece might make another one.
Yeah, there's
So maybe
nobody
that
here.
makes
Let's try.
14. Maybe these two together make
Start
15.
the hospital.
Maybe this here and here makes
I'm bringing the
16.
stages out.
17. 18. 19. 20. 21. 22. 23 with this little corner. Okay, so maybe I can count in that sense. Like maybe I can keep going and count the squares in that way. Did anyone think of
One
doing
down.
that?
Hold on.
Throwing a grenade.
No? Okay, so that would be a possible scenario.
Throwing a grenade.
Not anymore.
Okay, so did anyone have a guess as to how many square units the area was? Sarah?
I got
Flashbang.
You got 10 square units? Okay. There's a guess, right? At least we've got a guess.
Flashbang.
Okay, Keelan said maybe 16 times 9. Okay, perhaps. Get this up here. Okay, 16 times 9. That would be 144. Okay, that's definitely a whole lot more than 10. Okay, I just counted about 24 squares. I feel like I missed one though. Oh yeah, I missed this guy here. Okay, so 25.
Down smoke.
Okay, so my estimate is somewhere between 24 and 25 square units. Did you guys think I was off there at all?
Throwing flashbang.
No? Did I miscount anywhere? Did you guys see what I did? So let me show that again. It isn't impossible if we use our estimation
hallway.
skills.
Just keep. Oh, one coming down.
Okay, and if I take some of those bigger pieces, so for sure I have a whole square unit here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. For sure I have 13 full square units that I can see. So if I try to fit together the rest, I could maybe make bigger ones. So this piece right here, this little guy right here, looks like the remainder of this square here. So maybe this piece and this piece together, so what did I say? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So maybe these pieces together make 14. Okay. There's a little piece here, so maybe this makes 15. Okay. This piece and this piece together maybe make 16. Okay, there's a little square up here, little corner here, and here, 17. 18. Let's go 19 here. 20 with this little piece. 21. 22. 23 with this little piece, 24, and then 25. So, does that seem reasonable when I push all these pieces together that I could potentially get maybe 25 square units? Does that seem reasonable? The way I counted it? Okay, so the other thing Lucas said, and I'm just going to cut this piece out here. Lucas had said, when I went into his group, he said, well, what if you rotate the square and make it fit on the square totally, and then see what it looks like? And I said, yeah, sure, that's not a bad idea. So, let me show you guys this. Okay, this little square, okay, see this square I cut out? Okay? If I put it on top, oh my gosh, I can't move it. If I put it on top of here, does this fit? Is this the right size? Does that look like it's the right size? I need some thumbs up or nods or something. Okay, yeah, that looks to be the right size. So Lucas, you're right. If I was to rotate this then, and actually put it on the grid in a different way, okay, I could see this, right, if I rotate it. Now it's straight. Can I see the side lengths now? Yeah, I can see that the side lengths are 1, 2, 3, 4, 5. And
Yeah,
1, 2, 3, 4, 5. And in fact,
They're all
I
like
did that on purpose. If I move this, you can see the grids now. Okay. So yeah, I have 5 by 5. What's 5 times 5?
One got the diagnostic room.
Eleanor.
25.
25, yeah. So was I accurate then with my counting? Yeah, I was pretty accurate, wasn't I? Okay, I think I need to zoom out on this so we can see it a little better. Okay. So, let's see here. Where am I at? Oops. Okay. So, kiddos. Let's see what this relationship is. Right now, we have decided that this is in fact equal to 25 square units, okay? It is in fact equal. I'm gonna get rid of that about sign. I proved it with Lucas's strategy of taking the square and actually rotating it, okay? So take a look at this number, 25 square units, 9 square units. Oh, I wish I used the other color. Okay, 16 square units. And your 9 square units, okay? So those three numbers, do they relate to each other in any way, shape, or form? How can they possibly be connected? Do you notice any connections between them? Any pattern? Sorry, Keely, you with it. Anna?
16 plus 9 is 25.
Yeah, 16 plus 9 is 25. Okay.
20 minus 9.
Sorry?
25 minus 16.
Yeah, it's the other way around as well. So, something we might notice. Okay, that, okay, 16 plus 9 gives us 25. Okay, and fact family, I can also say that 25 minus 16 gives me 9. I can also say 25 minus 9 gives me 16. Okay. So far, so good, everyone? That's the relationship here, okay? So, what other, what have I got here? Alright. So I also want to point out some other terminology. Okay. So you're going to, I'm going to draw, what would I do here? Okay. So there's my yellow arrow here, okay? So this baseline and the height line of my right triangle, there's another terminology we use in particular for right triangle. We like to call these the leg, okay, the leg of a right triangle. Okay, the leg of a right triangle.
Together we can do this.
So both, okay, both of those are the legs of the right triangle. Can you guys read that yellow okay? Yeah? Okay. The legs of the right triangle are two sides that intersect to determine the right angle. So the right angle will always be between the two legs. Okay. So the legs of a right triangle are the two sides that intersect to determine the right angle. Okay, so now you guys know what the hypotenuse is, you know what the legs are, you know where the 90-degree angle is. Okay, so when I color code this, one of my legs was blue, one of my legs was orange, okay, and my area, my hypotenuse, okay, was green. That's what I made it do. Okay, so this was the area of the hypotenuse, right? The area of the hypotenuse. Equals, whoops, not equals, minus the area of leg 1, how about, equals the area of leg 2. So far, that's what we can see there. Okay, so I'm going to present a question to you. Okay. Present. Sure. Okay, so I want you to take a look at this one, and you don't have to draw it's the two square areas of the leg, and we determine the area of the hypotenuse and how those are connected with one another. Okay, knowing this sort of connection, how could you apply that connection to this one? So on this diagram, you guys can see my mouse on here, right? Can you see my mouse floating or no? Yeah? Okay, good. So notice this right triangle is upside down. Okay, it's not have the same orientation. Okay, this is where the 90-degree angle is. So that means that this is a leg, and this is a leg. This is the hypotenuse. Okay, so this is 29 square units, so I'm telling you that this area is 29 square units. And I'm telling you that the area of this leg is 4 square units. How could you possibly determine the area, okay, of this square? So using this same concept here, if you know the area of the hypotenuse, okay, could you determine the area of this leg if you're given this area and this area? What might they be? Okay, thinking about this. So I can do area of the hypotenuse minus the area of the leg equals the area of this leg. Okay, I also know that the area of, okay, the area of one leg plus the area of the other leg will give me the area of the hypotenuse. Okay, so thinking about that relationship, what would you get as the area of this leg over here? thinks they know? Who thinks they know what the area is? Grayson.
25.
Yeah, how did you get that?
29 squared minus the 4 units squared.
Perfect, exactly. So you took this same concept, and you said the area of
These
the
are okay.
hypotenuse
These are
side,
smart,
so
smart.
29, minus the area of one of the legs, so minus 4 will give me the area of the other leg, so 25. So you are good. Good job. Okay. Let me. Oh, yeah. Okay. So I've got a. Oh, I forgot what time it is. I feel like it was the first block, but it's not. Okay. So we'll come back to this. Don't put your math away because I want to finish this up today. So we'll come back to this, but you guys can start your little 15-minute break. Okie dokie. See you in a bit.
That was surprisingly easy for class.
So I turned off my Google Meet. My game is so much smoother.
Huh. That same.
I can fucking
There's
tap
someone
it.
camping behind SWAT car. And they go on about it again.
Ah,
Who's Lucas?
he's JVK.
How could you? Can you see your ass?
God damn.
Hey, I got you!
You fucking
Yeah.
sprayed the wall. All you did was
You're
spray the wall.
helpless. Or is that
Yep,
just me?
and I still got you.
I was focusing on the other guy. God damn it.
Oh, there we go. You.
Oh.
Wait, are you on counter?
Yeah, I got auto balanced.
Oh no, should I buy an off? I don't
No.
feel.
Your ass. Boy, ass it. Often takes skill.
It does. I'm just a normal user for a. Oh, there you
Got
go.
your
Oh,
ass.
shot it.
Are there two?
Dead.
Yeah. Yeah, they're all in the shed.
Now they're all.
2 of them in shed.
Yeah. Nice. Oh, he's on the shed.
Peek your head.
He's
Peek your head.
risk for most eliminations.
Ooh, look at this block. Ooh. Lucas, don't pick block.
Go, go, go!
Lucas, pick block.
Alright.
Look on the ground, dumbass.
There, I took it.
Dude, I died.
What? Ugh.
They're seriously behind SWAT again.
Are they can't?
Yeah,
My
they
teammates
are.
are such cowards.
Are they camping behind SWAT vans?
Yeah, they're such cowards. I'm the only one actually pushing. Oh yeah, they're all on.
Oh, come on.
This guy's a fucking scar. That's people who use the scar.
I have to agree with
They're
that.
pushing out of
It's
shed.
one of the easiest weapons to use, and it's
Yeah, but look, this guy
disgusting.
has 4 HP. If he falls off the roof, he'll die.
I'd like to see him just kind of walk off while trying to look at his target. Oh, there it is.
Oh, this guy's pretty good fuck. What? Look at Glutton. Glutton doesn't see him. Glutton, Risk doesn't see Glutton either. They just walk past each other.
How did they
Oh
not see?
my Jesus fucking
Now
There
we
we
go.
go.
dude.
He's got a hostage now.
Fucking low level lobbies are so dumb.
Just so funny too.
Walk out. This guy's plugging the walk out front door. Yep.
Oh yeah. Oh, there he goes.
Wow. Hey, Risk. Look at him, bro. Look at him, Risk. Come on.
Look at front of
Come on, Risk. Come on. Tell me
He's
you see him.
looking.
Oh, he saw him. Damn, that's a clutch.
Not really. That blue team or CT was really fucking stupid.
I can confirm. My
Wait,
teammates are
how
just
did-
little.
Glenn
They're just SWAT
walked
van
past him.
campers.
He walked past him and just didn't think anything of it. Oh, are they all in the barn now?
Oh, fuck, I can't.
Are they all in
You're welcome.
Are they all in shed?
Oh, you got. Yeah,
They are.
all of us. We're all in shed.
They're
Well,
all
by
in
all-
shed. You're
By
joking.
all, I mean there's one. Good luck, glutton. Yeah, you can find it. Yeah. Oh, where's the last dude? Oh,
Where's the... Is he a SWAT camping van boy?
sneaky man.
Is he going for the hostages?
Just wait.
Oh, there you go, Luis.
He's going through front doors,
Oh,
isn't he?
what the fuck? Where is he? No, I just got shot.
He's a ghost.
He's right behind that rock.
Throwing the flashback.
Oh, it's... Oh, he's on roof
Hey,
now.
hey, you fools! Look at them. That was so sad to watch.
I'm killing him with a pistol. I can't do
What?
it.
It really was... He's got...
I just killed him with a pistol. You guys couldn't kill him with guns. I just fucking pistol tapped his ass.
Oh my god.
Match point. Let's go.
Let's go, let's go.
Nobody expects a Spanish Inquisition.
Keelan, come for your rat hole again. I dare you.
What rat hole?
I know your rat hole. I know your little rat hole. Think you can get free.
Fuck, I had him right in the head too. Wait, if we lose this one, it's fine.
I hear their footsteps. I'm scared of Keelan coming up on me.
Yeah, good luck, Lucas. They're all in their spawn, by the way, Lucas.
They all.
Yup. Because they have hostage. Lucas, kill him, kill him, kill him. Kill him.
Yeah, fucking kick Lucas.
Kill
Come on.
him! Kill him!
Kill him. Oh, you got one. You got me.
Imagine having to use like guns with a scope.
Easy. We kill them, and then we go home.
Sorry, I didn't hear that.
What?
Your mic.
I couldn't
Imagine
hear that
having
either.
to use a gun with a scope that isn't a sniper.
Oh, that's me.
Hold on, I'm gonna spectate you, Mister. As we see Keelan coming up from his closet hole.
Oh, I almost got you, Atlas. If you hadn't moved away. If you hadn't moved, I would have domed you.
Now Atlas heading into sewer.
Where's that
Nope.
gun?
Uh,
I wanted the gun! Come on!
He just wanted the gun.
I just wanted the gun.
He's he died.
And
And we lost. They have hostage.
is that another hostage win?
Yep.
Why do they always go out that? It's like not a good spot to come
Well,
out
that's
of.
predictable. Now I know where they're going, so I can hide, you'll see. I got a good hide spot.
Well, I guess I better take hostage this round.
I'll find you.
They can't be hostages if you kill them.
Oh, that
You
is
lose
true.
money if you shoot the hostage somehow.
No more talking. Now we
The
go.
hostage is what your
Is the
bank
government
account
gonna
dies.
tax you for shooting the hostage or something? I was using a whatever that weapon is.
I'm the chicken killer. Oh,
now.
there you are. Yeah, I'm not gonna go there.
Dylan, come out your other hole. Oh, and this kid with the scar?
Yeah, he doesn't like looking at.
Alright. 7 HP. Oh no, look, Keel's got my hostage.
Woohoo!
Oh, you're using an LMG. Yeah.
This is funny.
Keelan, clutch or kick?
What?
You either grab the hostage and escape freely, or you
Oh no, that's where you were! Oh, I was wondering where you were.
Ace. With the LMG.
Damn.
You don't know how hard it is
gremlin.
to control that LMG recoil. That thing fucking shoots you backwards. It fucking
Launches you into the second dimension.
It does.
Hey, I was the colonel.
Revolver
Most
case.
chicken murders.
That's I don't think that's a good thing. Right?
The chickens. They're insignificant. Now, because I gotta go get a snake, I'll be back.
I probably had the lowest accuracy because the last round with the LMG where I just fucking beamed them. They got fucking lasered.
What team are you going on?
Let's join CG.
Alright. Wow, immediately got fucking wallbanged into outer space.
Banana.
Can you block the ladder? Oh, you're on CT again! Ah. Or wait, hold up. We're on CT. Okay,
Poor
cool.
terrorists. All they have
Poor
are bots.
terrorists.
If we win this one, I might join
Wow. There's one under
Behind the
bridge
truck.
behind the truck.
Yep.
Counter-terrorists win.
Oh. 7%.
They have one real person on there. Alright, Lucas, you
Make
stay there.
that two.
Oh, nope. Nope, they,
Oh,
you got moved
Move
back.
it,
Oh.
move it. Stop, you're
What is your
Nope.
profile pick, Atlas?
Don't worry about it.
That's what I want to know.
Don't worry about it. Guys, don't go
Maybe
there.
I should worry about it.
Oh, we gotta join the call now.
Sick.
Bro, one's outside the door, he hasn't opened it yet.
I'll surprise them at their escape area. Flashbang! You are leading on.
Alright, kiddos.
Ow, my fucking ear hurts. Like it's
So,
a-
camera's back on as you're rejoining us.
I look here.
Okay. Torrance camera, Owen camera.
What? Billy, I need help here.
Whoa, whoa, whoa.
Thank you, thank you. Courtney, are you there?
3 men left.
Oh, down in her
Oh,
chair.
shit.
See.
He's got one
You know,
tap.
what's this there?
Oh,
I'm
I'm not
at
enemy.
18. I'm
It's
at
absolute
18
lag.
and 17, so like in one person.
One through the wall.
That was easy. Oh no, they're right there, never mind. Not easy. Eleanor, Keelan,
MP
Alan, Tristan, Trinity, Anna, Aisha, and Josh maybe? That makes sense. Alright. Okay, okay. You can see that I am presenting a screen. It should play the audio. Can you guys just confirm when I start playing that you can hear the audio?
Oh no.
Thank you, Eleanor, for your thumbs up. Thanks, Grayson.
Hey everyone, in this video we are going to explore the meaning of the Pythagorean theorem.
They're outside.
The Pythagorean
Under
theorem
bridge.
is based on a special relationship between squares and right triangles. Remember, a square is a four-sided shape with four 90-degree angles and equal
Yeah,
side
they're
lengths.
everywhere.
A right triangle has
You
one
realize you can
90-degree
control
angle
bots, Lucas?
and
Oh no,
has
he's
three
not playing
sides with two sides
can?
connected in a
it.
perpendicular.
Yeah, go on a bot that's
Now,
not being
let's
controlled
see
and
what's
press E.
so special about these shapes. Here is a
Press
right
D.
triangle. It has a
Hmm.
height of 3 units, a base of 4 units, and a diagonal length of... But it's hard to tell exactly
Atlas,
how long it
breathe.
is.
You could
An important thing
breathe.
to know about
Oh,
the diagonal
shit.
length is called the hypotenuse. The hypotenuse is the longest side of the right triangle. So
What do
we
you have
know
to press
2
the
out of
next
3 of the side lengths.
Over how loud
But
the fucking
how
class
can we
is.
determine the length of the hypotenuse?
Let's go, my brother.
Let's create some squares using the triangle lengths. This square will have dimensions 3 by 3, so it has an area of 9 square units. This square will have dimensions of 4 by 4, so it has an area of 16 square units.
I can see that.
Again, we don't know the area of the square created by the hypotenuse because we don't know the length of the hypotenuse. So let's see how the large square compares to the smaller squares.
Damn it again.
Oh, they're down there.
Notice that the
Oh, I hit him.
is equal to the area of both squares created by the height and base of the triangle.
Ah,
We know that the area of a square can be represented by the side square. So let's call this side A. This side B, and the hypotenuse can be side C. The
Lucas, go
relationship
vents,
shown
I dare you.
is the area
I'm
of
not
the
going
square
vents.
created by side A of the
Come on, do it.
triangle
Why would I
Do it.
No, no.
Tell your
combined
teammates to
or
go
added
vents then.
with
Do it, you
the
won't.
area of the square created by side B
There is one.
equal to the area of the square created by the hypotenuse, or side C. Let's try another example. Here is another right
You're a
triangle.
shot, Johnny.
Let's call this side A.
You're
It is
casting with a
6 units
shotgun
long,
in bed.
creating a
Nice.
Oh,
with an area of 36 square
though.
units. Let's call this
Triangle out
side
of
B.
vents.
It is 8 units long, creating an 8 by 8 square with an area of 64
oh, we
square
finished
units.
this round, so your team.
The
Oh,
hypotenuse
you're
can be
gonna.
called side C, and we
Well,
don't know the
I'm
side
dead.
length
And
or
it's
the area of the square created.
They
Our
took you
rule
out.
means the area of side
The
A
lag.
added to the area created by side B. 36 square units added to 64 square When they're added together, that number would be 100.
I have negative
so
1 kills.
The yellow square should be
How do you
100
have
units.
negative?
I don't know.
All
How do
64
you
green
go
squares
that
and all 36 red squares do fit perfectly into the yellow square.
Avenue place.
But we still don't know the
Okay.
side lengths of the triangle,
I died
which is
first.
what we have been trying to determine.
Oh
We
my
know
god,
side
that's a
A
gremlin
is
spot for a shotgun if I've ever seen
Yeah,
one.
Watson,
side
there's
B
a
is
door right
8.
here.
Well, if we know the total area of the square, of the area to determine the side length. The square root of
That is a
36
gremlin shotgun.
is 6, and the square root of 64 is 8. So the square root of 100 will give us side length C.
They're
In
taking
this
the
example,
hostage.
C is equal to
Oh, he has an
for
auto.
our
Of course
answer.
he had an auto.
Sorry.
So, the Pythagorean theorem is 2 out of 3
type of
sides
people
of a
are
right
dying?
triangle. You can use the relationship of the area of the squares
gonna
created
go
by
there
the
this
side
time.
lengths to determine the missing side length. Find the areas of the squares created by the known lengths. Add or subtract the values to find the area of the third square. Then, take
This
the
is a
square root
shotgun
of the
squad
area
if I've
to
ever
determine
seen
the
one.
missing
Let's
side
go.
length. Hopefully this helps you to better understand and visualize the Pythagorean theorem.
On bridge. He's using his star.
Oh, Jesus.
So, I mean, that video is very but that is the idea. So if I go back to, okay, if you guys are looking at my camera screen here, if I go back to this example then, and let's say
Yeah, they took
all we knew was the 16 and the 9, right? So the formula was leg squared plus leg squared equals hypotenuse squared. Okay? So this is area plus area equals area.
Now, how do you
The
get on?
A, the B, and the C represent the side length
Jump on this
of
little
those
box
squares.
right
You
here.
guys can't see what I'm writing. Sorry. Okay?
What box?
So if I have one leg, okay, I know that I have, let's say,
I don't think I can do
my
it.
leg that was 4 units, right?
Yeah.
So I know I have 4.
Just sit
And if I square that, I'll get the area. And then my other square was 3 units. So if I square that, I'll get the area. And they're saying that that will give me the area of my hypotenuse. So 16, okay, plus 9 gives me 25. Oh, let me write this differently. Okay, the area of my hypotenuse. Oh my goodness. Can that write nicely? Maybe, maybe not. There we go. Okay, so I get 25 equals my area squared. So what we're saying now is, what you know about area of a square is that it is squaring the side length.
with an LMG.
And you know that
last one's
the inverse of that
by
to find the side length is to square
like
root
Victor.
the area. Okay, we already know that from talking about squares.
He's in their spot.
So if that's the
No, it's
case,
not. Take a right.
if 25 represents
Closed door.
my hypotenuse squared, so that's giving me the area, this is area of the square attached to my hypotenuse, then I should be able to do the inverse operation to find my unknown value. So if this is what I have right now, A equals C squared, to figure out what my side length is, just like algebra, I should be able to square root, which is the inverse of squaring a number, and what I do to one side, I must do to the other.
Everyone deserves to live in this society.
Okay, so the inverse operations of squaring a number. So what I do to one side, I must do to the other. So if I square root a square, those cancel each other out, and I end up with just the C. And square root of 25 is 5. Okay, so right now, this is the side length
I'm sorry, how many times did it?
of my hypotenuse, and this is the area of my hypotenuse.
I just shot a dead body, so I thought it was a person.
So Pythagorean theorem is stating that for any right triangle, okay, so this works for any right triangle, the square of the length of the hypotenuse equals the sum of the squares of the length of the legs of the right triangle. And we can use the formula a squared plus b squared equals c squared. Okay. So where a and b represent the legs and c represents the hypotenuse. Okay, so that's Pythagorean theorem formula. And so that statement is that for any right triangle. Does that mean that I could use this formula for an isosceles triangle? Thumbs up if you think I should be able to use this with an isosceles. Thumbs down if you don't think I should be able to use it with isosceles. Yeah, so your thumb should be down. Okay, so this only works for right-angled triangles. I cannot use this formula for any other type of triangle. So the triangle has to be a right-angled triangle where it has the 90 degrees. Okay, if it is not stated, or if you know the triangle is not a right-angled triangle, then this this Pythagorean theorem, the Pythagorean relationship does not apply. Okay. All right, so I think I'm going to leave that there for today. Tomorrow we're going to continue to work on this, and the next day and the next day. So you guys can put your math away for now. And I'll tidy my area up here too. Turn my camera back to me.
They got hostage. I already got boxes.
Alan, are you there?
Yeah, I'm here.
Good. Glad to hear.
They got hostage.
Okay. Okay. I got to do this tomorrow. All right. Science. So, tidy this up a bit here. This guy, pencil, scissors. Calculator. All right. Let me just get rid of this.
Where? My tab is
Sorry,
my
guys.
thing's untabbed. Fuck.
Save the presentation. Alrighty. Okay, so on the science classroom page, you might have noticed, I just want to give you kind of a heads up. So you might have noticed too that I'm kind of reviewing things a bit this week for science. So the cow eye dissection is supposed to be, the virtual cow eye dissection, I should say, that we started yesterday is supposed to be a really good review of how our eye works and all the different parts of the eye. So remember, hint, 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 that's what you need to know for your next assessment. I've been thinking a lot about assessing you guys on light and optics, and I'm really struggling with the whole thing because part of me wants to wait until next week when you guys are back in person to do that science assessment. So what I'm thinking is, and I'll just pull up my calendar here. Go to the top instead. So next week, Thursday, is when we supposedly come back to in person, which is what I'm really hoping for. So I'm thinking I'd like to put lessons 5 through, let's just say I get to 10. We'll see here. Light and optics test. Not complementary color. Oops. Okay, so I'm thinking that I want to give you guys that test on the 6th. Okay, so you're paying attention. That would be the day you guys come back in person. So right away a test. And part of the reason I want to do that is because this is what's going to happen. We're here. We're on this week right now. This is where we are. I've got a little something today. Have a little something tomorrow. You guys will have another class on Friday. And I'm thinking that's it for light and optics. And then I'm going to be starting on Monday mechanical systems. So I'm going to be starting a whole other unit. So mechanical systems Monday, Tuesday, Wednesday. So that means it's up to you to study the weekend leading up. So this weekend coming up here, May 1st and 2nd, 3rd, 4th, and 5th to be prepared for the 6th. Can you guys handle that? So the trouble with that, and that's what I mean by this, I hate doing the science assessments online if I don't have to. So I'm thinking I'll put it in. If for some reason we get extended into online even further than this date, then I will keep that date as the assessment date and we'll do it online. Okay? Does that sound good? I see one thumb up. Is everybody listening to me? Okay. All right. So that's the plan. So this will be in person, hopefully. If not, we'll just do it online. But be prepared because I am starting a whole other unit next week. Okay, so unfortunately, sometimes that gets a little confusing. Just have that on your mind. Okay, so back to science. This morning I posted just on the stream, so I didn't put it in the classwork section anyway. But I posted on the stream, if you have a printer at home, print these 2 documents. I think it's awesome if you could work with these 2 documents. They pretty much have to be printed. So if you can try to print them today at some point, get your parents to try and help you, or if you can email them to your parents at work, if they can print it for you, I don't know. If you can't, I can, if you can let me know right now that you can, I can print some and you guys can swing by the school afterwards. I don't know, but the reality is that with the ray diagrams, it's so much better to do by hand, right? So if you're able to print, that would be awesome. Or if you're able to get your parents to help you to print them. Don't need them today, but if you're able to get that done for the next day, that would be great. Okay. Any questions about that? Okay. All right. So I just have a couple of things to share with you. One of the things I didn't feel like we spent enough time on, if you guys recall, lesson 5 part 3 was the optical technology research that you guys did. Now you have to research binoculars, reflecting telescope, refracting telescope, or some other option, but as a result you yourself only researched one particular topic. I did share some of them, but it didn't really go into it in great detail, so I'd like to talk about telescopes a little bit more here to start, if I can find my document. Where am I?
Let's get this done.
Let me think. Or do I want to do this?
Why are you
Let's
using
try and
Star
make up your
Atlas?
mind. Oh yeah, no, I want to do that another day. So, what I'll do is lesson 5, part 3, extended. Material.
Scouting the stages. I'm bringing the stages out. Hostage has been rescued.
I had to distract him so he
Switch
could
it to just you guys.
Let's go.
Are you opping?
I might be.
I know you are.
Okay. So if you go to the classroom page, okay, I just posted, you might have to refresh this. Go to the classroom page and click on this first document, which is telescope pre-reading.
I'm bringing the stages out.
You are opping.
Okay, and this is the first document that you should click on.
Let's move out.
Okay, light and optical systems. Okay, on optical systems. Okay, so you're following along. 7. Oh my gosh, Siri, stop talking. Okay. How come I only have a total of 11 viewers? Is that because you're looking at my screen instead?
Escorting the stages.
Wait, telescope. That's the one I'm in right now, so you should not be in the other one. So, Keelan, you don't need to be in the other one right now. Okay, telescope pre-reading. So, it starts with, and I still have only 11 viewers, so I'm hoping that means that you're looking at my screen instead. Sarah, you're looking at my screen or are you on hand? Sarah? Can you hear me? Yeah? Okay, good. Okay, to understand how telescopes work, let's ask the following question. Why can't you see an object that is far away? For example, why can't you read the writing on a dime when it is 55 meters away with your naked eye? The answer to this question is simple. The object does not take up much space on your eye's retina. If you want to think about it in digital camera terms, at 55 meters, the writing on the dime does not cover enough pixels on your retinal sensor for you to read the writing. So it's too small, okay, too small of an image on your retina. If you had a bigger eye, you could collect far more light from the object and create a brighter image. And then you could magnify part of that image so that it stretches out over more pixels on your retina. Two pieces in a telescope make this possible. So the objective or primary lens in refracting telescopes, or the primary mirror in reflecting telescopes, collects lots of light from a distant object and brings that light or image to a point close to it. An eyepiece lens takes the bright light from the focus of the objective lens or primary mirror and spreads it out and magnifies it, okay, to take up a larger portion of your retina.
So the objective and primary lens or primary mirror collects a lot of light from distant objects. Okay, so it collects so much light, okay, to a primary point of focus, and then your eyepiece lens makes that so that it takes up a greater portion of your retina. This is the same principle that a magnifying glass lens uses. It takes a small image on the paper and spreads it out over the retina of your eye so that it looks bigger. Okay. When you combine the objective and primary lens or primary mirror with the eyepiece, you have a telescope. Okay, so overall, you have an objective lens or a primary lens or a primary mirror that is collecting a ton of light. Okay, and focusing it onto one focal point, and the eyepiece lens is what then magnifies it into your eye so that your retina gets enough of the image to see. Okay? Again, the basic idea is to collect a lot of light to form a bright image inside the telescope, and then use something like a magnifying glass to magnify or enlarge that bright image so that it takes up a lot of space on your retina. So I think this is a really good kind of summary as to how a telescope works, so hopefully that everybody kind of understands that the telescope has two general properties, okay? So how well it can collect light and how much it can magnify the image. So overall, if you're looking over here, right, your eyeball's over here and you have an eyepiece, light coming from far, far, far away is being collected to this focal point. And then that light is then going to be magnified into your eye through the eyepiece lens. Okay, and granted, this lens here will flip the image again, which is then flipped again on your retina, and it goes through the lens of your eyeball, so it's flipped twice, and then your retina and your optic nerve what it's seeing. Okay. Questions about that one? So it's just kind of a nice little review piece, a nice little review reading piece, just so you guys have an understanding about telescopes, because on that assessment next week, I could likely ask you about a telescope and how it improves our sight. How does that work exactly? And so you kind of need to have a general idea, right? Okay, so that was the first one there. And then open up the next one, which is, okay, the next one is why are telescopes important? Okay, so this one I find really cool because it's more relatable, and you guys know that I really love the idea or the concept of science, of space. So this to me is just why why this type of technology is so important to us as human beings and as a species on this planet. Okay, so you're following along on this. All right, consider this. On April 13th, Friday the 13th, in 2029, millions of people are going to go outside, look up, and marvel at where they've left. A point of light will be gliding across the sky faster than any satellite and brighter than most stars. What's so lucky about that? It's asteroid 2004 MN4, not hitting Earth. Okay? For a while, astronomers thought it might. On Christmas Eve of 2004, Paul Chodas, Steve Chesley, and Don Yeomans at NASA's Near-Earth Object Program office calculated a 1 in 60 chance that 2004 MN4 would collide with Earth, and the impact date is supposed to be April 13th, 2021. The asteroid is about 320 meters wide. Okay, so I want you to kind of think about that. Okay, think about how far a meter, so picture a meter stick, okay, and multiply that by 320 meters. Okay, think about how wide that asteroid is. It's wider than some buildings, okay, wider than a field. Okay, think about that. The asteroid is about 300 meters wide, that's big enough to cover the Earth's atmosphere, devastating the size of, let's say, Texas. So if an asteroid was to hit land, causing widespread tsunamis, you guys know what a tsunami is? Thumbs up if you do. Okay, good. If it hit the ocean, says Totus, so much for your holiday cheer. That would not be good. Okay. Asteroid 2004 NN4 has been discovered in June 2004, lost, then discovered again 6 months later. With such sparse tracking data, it was difficult to say precisely where the asteroid would go. A collision with Earth was theoretically possible. We weren't too worried, Toda says, but the odds were disturbing. This is typical, by the way, of newly discovered asteroids. Step 1, an asteroid is discovered. Okay, so we see an asteroid. Step 2, uncertain orbits are calculated from spotty tracking data. Step 3, possible Earth impacts are noted. And step 4, astronomers watch the asteroid for a while, then realize that it's going to miss our planet. So panic and then relax. Okay, killer asteroid. Headlines generally appear between steps 3 and 4, but that's another story. Astronomers knew that 2004 NN4 would miss Earth when they found pictures of the asteroid beacon unwittingly in March of 2004, 3 months before its official discovery. The extra data ruled out a collision in 2021. Instead, what we're going to have is an eye-popping close encounter. So on April 13th of 2029, asteroid 2004 MN4 will fly past Earth only 18,600 miles, so that's about 30,000 kilometers above the ground. So for comparison, geosynchronous satellites orbit at about 36,000 kilometers from our planet. Okay, so let that sink in a little bit. Okay. Our satellites that we put up into our orbit, they are about 36,000 kilometers from our ground. What they're suggesting is that this asteroid will miss our planet, but within that range, which is like scary. Okay. At closest approach, the asteroid will shine like a third magnitude star. Visible to the unaided eye from Africa, Europe, and Asia, even through city lights. Says John of JPL. This is rare. Close approaches by objects as large as 2004 MN4 are currently thought to occur at 1,000-year intervals on average. So they're saying this kind of thing typically doesn't happen very often. Okay, maybe once every 1,000 years. So if we take a look at this, and this is Earth, okay, do you guys see where Earth is right here? Okay. This is how far the moon is from Earth. Okay, this is what they expect the trajectory of the asteroid to be. This line right here, and it'll just go right past Earth. Okay, but that is close. Okay, a little too close for comfort. The asteroid's trajectory will bend approximately 28 degrees during the encounter, a result of Earth's gravitational pull. Okay, so it bends because it gets close to Earth. We tend to pull things a bit closer to us. That happens to all planets, right? What happens next is uncertain. Some newspapers have stated that the asteroid might swing around and hit Earth after all in 2035 or so. But Giorgini discounts that our ability to see where 2004 MN4 will go by extrapolating its orbit is so blurred out by the 2029 Earth encounter, it can't even be said for certain what side of the sun 2004 MN4 will be on in 2035. The talk of Earth encounters in 2035 is crazy. So at the end of the day, our sun has a far greater gravitational pull than anything else. The reason why our 8 planets circle the sun is because the sun's gravitational pull still has those 8 planets in orbit. So it's too soon to tell what kind of effect the sun's gravitational pull will have on that asteroid. In 2004, a team of astronomers led by Lance Benner of JPL obtained 2004 MN4 using the giant Arecibo radar in Puerto Rico. Coincidentally, the Arecibo dish is about the same size as the asteroid. Echoes reveal the asteroid's precise distance and velocity, allowing us to calculate the details of the 2029 flyby. All right. More data are needed to forecast 2004 MN4's motion beyond 2029. The next good opportunities are in 2013, so that's already gone, and 2021. That's where we are right now. The asteroid will be about 9 million miles, so 14 million kilometers from Earth, invisible to the naked eye, so not something we can see, but close enough for radar studies. If we get radar ranging in 2013, we should be able to predict the location of 2004 MN4 out to at least 2070. Okay? NASA's NEO Near-Earth Object Program was greatly shorted after a near miss. So in 1989, a 300 meter or 1,000-foot diameter Apollo asteroid, this is the name of the asteroid, missed the Earth by 700,000 kilometers. Now that's further than this other one that we're talking about. The other one that we're talking about was saying 30,000 kilometers close to Earth. This one was 700,000 kilometers. I mean, that was a whole lot more further away. But they still consider that a near miss. So 700,000 kilometers is about 400,000 miles, passing through the exact position where the Earth was only 6 hours before. So in 1989, we had an asteroid that passed us, and it passed through the position where our Earth was 6 hours before that. Now, had the asteroid come 6 hours earlier, it would have hit us. If the asteroid had impacted, it would have created the largest explosion in recorded history. It attracted widespread attention as early calculations had its passage being as close as 40,000 miles from the Earth, with large uncertainties that allowed for the possibility of it striking the Earth.